Okay, so we've all seen one of these, and let's be honest, for some of us it brings back great memories, for others, maybe a little bit of anxiety. Yeah, the math textbook. It's just a fixture of our school years, right? But today we're going to peel back the cover and look at it in a totally new way. We're going to deconstruct it and reveal the hidden architecture that was designed to literally shape our minds. So let me start with a question. When you look at this, what do you really see? A bunch of formulas? A heavy book you had to lug around? Well, this explainer is built on a totally different idea. That what you're actually looking at is a meticulously engineered tool, a device crafted with a very specific purpose to build your mathematical brain from the ground up. Let's dig in and see how. First up, who are the master builders behind a tool like this? It's pretty easy to think they're just cranked out by some faceless corporation. But you know what? The reality is way more interesting. I mean, just take a look at the brain power we're talking about here. These aren't just random writers. This is a team of decorated mathematicians and truly passionate educators. We've got specialists in number theory, award-winning teachers, even heads of university math departments. These are people who've dedicated their entire lives, not just to doing math, but to figuring out how to share it effectively. And that's really the crucial point. The textbook in your hands isn't some anonymous monolith. It's a carefully curated collection of knowledge put together by genuine experts who are deeply, deeply passionate about education. That combination of passion and expertise, that's the real foundation of the book's entire design. So now that we know who builds it, we can get into the really cool part. How they build it. Because this isn't just a random pile of chapters. It's a deliberate blueprint for learning. A structure designed to guide your brain from one level of understanding to the next. At the very heart of the design is this really clear learning cycle. See, every single chapter kicks off with a pretest, just to see what you already know. From there, you jump into the skill exercises to build that core fluency. Then, a review exercise helps all that knowledge sink in. And it all leads up to the challenge exercise, where you're asked to apply everything you've just learned to new creative problems. This four-step journey from competence to creativity is repeated for every single topic. It's intentional. And woven into that whole structure is this core philosophy. The authors call it the proficiency strands. Now, what that really means is that every single exercise, from the dead simple to the super complex, is designed to build 4 key skills all at the same time. Understanding the concepts, fluency with the mechanics, problem solving in new situations, and the ability to reason and justify your methods. It's a totally holistic approach to building a mathematical mind. And when you zoom out, you can really see how this philosophy shapes the entire curriculum. The book is so carefully balanced. Yeah, it focuses heavily on the core pillars like number, algebra, and geometry, but it also carves out dedicated space for statistics and probability. And crucially, it dedicates a big chunk to integrated problem solving, which is kind of the glue that ties all the other skills together. Okay, now for the really fun part. Let's see this whole design in action. How does a book actually take you from doing a simple, routine calculation to solving a complex riddle? Just look at this comparison. It's perfect. On the left, you've got a basic skill exercise. Calculate 28 times 36. Simple. It's all about mastering a core mechanic. But then, in the challenge section of that same chapter, you get this. A puzzle about a family with birds and beasts, 36 heads and 100 feet. It uses the exact same fundamental math, but it asks you to apply it in a completely new, kind of abstract way. That is the learning gradient, right there in action. And that right there reveals the true purpose of the whole thing. The goal of that riddle isn't really to find out how many birds and beasts are there. The real goal is to build the mental muscles, the logic, the problem solving, the reasoning that let you tackle a problem you've never ever seen before. It's about forging the tools, not just collecting the answers. So, after all this careful design, you've got the expert authors, the learning cycles, the challenges. What's the ultimate equation? What's the end game of this entire endeavor? Well, you don't even have to guess. The authors state it plainly, right there in the preface. The goal is that students will have a strong foundation for work or further study. It's a simple mission statement, but a really powerful one. And this really gets to the heart of it. A well-designed textbook isn't about cramming facts to pass one test. It's about methodically building a foundation of skills and thinking patterns that are going to serve you for the rest of your life, whether you end up in science, engineering, or frankly, any field that requires clear, logical thought. So in the end, a math textbook is so much more than a book. It's a map for the mind. It's a guide that's designed to lead you to a whole new way of thinking. Which, I think, leaves us with one final question. What other hitting maps, what other carefully designed tools for thinking are you using every single day without even realizing it? Thanks for watching.